Hey, grade 7s, this is 1.2, factors and multiples. Some terminology here we're going to be looking at. What is a factor, prime numbers, composite numbers, common factors, and Waldo. That's what we're looking for today. So a factor is a number that divides exactly into another number. So you take a number like 10, which is a composite number. We'll go into that in a second. 2 divides evenly into 10 because it's 5, or 2 times 5. And ergo, 5 also divides evenly into 10 because it's 2 times 5. But 1 is also a factor because it's 1 times 10 makes 10. And that's the complete list of factors for 10. There's another way of looking at it, by looking at what's called a factor rainbow. So what you do is you start off on the left-hand side, and every single number has 1 as a factor. So you're like, okay, well, 1 times what makes 20? So you follow the arc, and you make the largest number on the right-hand side, 1 times 20. Then you go to the next number, 2. Is 2 a factor of 20? Does 2 times something evenly go into 20? Yeah, absolutely. 2 times 10 goes there. 3. Well, there's no number when I multiply by 3 that can go evenly, into 20. So there's no 3. 4. Well, 4 times 5 is 5. 5 times 4, but that's the same thing as this. So this is once I reach the same as backwards, or when I do 4 times 5 and then 5 times 4, I can go no further. That is the complete list of factors for the number 20. So I want you to list all the numbers, the factors for the following numbers, 8, 12, and 15. You can use a rainbow. So you can go like 1 and 8, obviously. Then you go 2. Well, 2 and 4. And then you go 3. No, 3 isn't. And then 4. Well, 4 is already in there, so I know I've reached the limit. 12. 1 and 12. 2, yep, and 6. 3 and 4. And then 4. Well, 4 is already there. That's it. That's your list. And then so on. Prime number only has 2 factors, 1 and itself. For example, there's 2, 3, 5, 7, 11, 13. It goes on and on and on. They only have 2 factors. If you look at 2, we go, well, 1 times 2, and 2, well, no, 2 times 1 is the same thing. So those are the only 2 factors. 3, 1 times 3, 2 does not divide evenly into 3, and 3 already is there, so we've already got that. What are the next 5 prime numbers after 5? So let's see if you can figure it out. Pause the video. There's 7, 11, 13, 17, and 19. Here's a little memory trick. For the first 5 prime numbers, just remember this at school. At 2:35, we go to 7-Eleven. You go get a super big gulp or something like that. So at 2:35, we go to 7-Eleven. There's the first 5 prime numbers. Now, prime numbers are really interesting in that they're all one type of number, with the exception of 2. And why is that? So let's go back to this list. 2, 3, 5, 7, 2, 3, 5, 7, 11, 17, and 19. You're going to notice that there's only one prime number that is an even number, and that's 2. And so the question is, why is every even number a composite number? I'm going to leave you with that question. I want you to figure that out. What is it about every single even number that makes it a composite number? A composite number means that it has more than 2 factors. So 3 fun factor facts. These are really fun. A composite number has more than 2 factors. For example, 1, 2, 3, 4, 6, 12 are all factors of the composite 12. It's a beautiful even number. And look at all the factors of 12. 1, 2, 3, 4, 6, 12. All those numbers are made up of 12. Sorry, 12 was made up of all of those numbers. 1 is only one factor, therefore is neither prime nor composite. So don't get confused with the number 1. It's not. It's neither one of them. Factors that are the same for 2 numbers are called common factors. That's what we're going to be doing next. Multiples of a number are found by multiplying the number by 1, by 2, by 3, or by 4, or by skip counting. So we take a look and I said, hey, what are the multiples of 3? Well, then you'd say, well, 1 times 3 is 3. Then you'd say 2 times 3 is 6. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 6 times 3 is 18. You're just skip counting. So it goes 3, 6, 9, 12, 15, 18, 21, 24, and on and on and on. Those are all multiples of 3. When you want to find what are called common multiples, you're going to see this a lot, common multiples between 2 numbers. So if you want to find common multiples between 4 and 6, we just make a list, and you do like skip counting. So you say 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. Then you do a list for 6, 6, 12, 18, 24, and so on. And then the simplest thing to do is just circle anything that is common. 4 is a multiple of 4, but it's not a multiple of 6. Next, 8. 8 appears in the list for 4s, but it does not appear in the list for 6s. 12 does. Boom, it gets a big circle. Boom, gets a big circle. And you go along, and you're going to find that there's lots of common multiples, especially between even numbers that are close together. LCM, so this is, you're going to hopefully remember this. This is the lowest, I'm not going to write this out, the lowest common multiple. And I'm going to show you this. Okay, so we're going to do this. Lowest common multiple of 12 and 5. So what you do is this. You get a hundreds chart, and we're going to make 12 is going to be blue. And so every time there's a 12, or multiples of 12, I'm going to be putting them blue. 5, we're going to make it, let's say, red. So every multiple of 5, so 5, 10. You're going to notice there's a pattern here. 40, 45, 50, 55, and oh, something happened on 60. Both 12 and 5 have a multiple of 60, and that is the very first common multiple. You notice this 5 is red because it's a multiple of 5, but it is not a multiple of 12. 10, 20, 30, 40, and 50, all of those are multiples of 5, but they are not multiples of 12. The same thing goes here. 12 is blue, 24 is blue, 36 is blue, 48 is blue, because they're all multiples of 12, but they're not multiples of 5. 60 is the first time where you have a number that is both a multiple of 12 and 5. That's the lowest common multiple. The greatest common factor, or factors, there's two ways of doing it. You can do a hundreds chart, or you can do a Venn diagram. So if the question says, find the greatest common factor of 30 and 24, we're doing factors, right? So we're dividing down. What you can do is, on one side, you can write all the factors of 24. And they're 1, 2, 3, 4, 6, 8, 12. And you write all the factors of 30. 1, 2, 3, 5, 10, 15, 6, 10, 15. The ones that that appear in both of them, for example, 1 appears in both factor of 24, and it also appears as a factor of 1, so it goes in the middle because it's a Venn diagram. That's the shared space. 2 is a factor of 24, but it's also a factor of 30. It goes in the middle. And 3 and 6. Now the question said, what is the greatest common factor? The greatest common factor. So we look at the common factors, 1, 2, 3, and 6, and which one is greatest? Boom, number 6 right there. That is our greatest common factor. If you look over here, I did the same sort of thing. I did, in blue, I did the factors that are common, 1, 2, 3, and 6. Yellow is factors of 24, and green are factors of 30. And you can see that the greatest common factor is 6, purple. You try this one. Find the greatest common factor of 28 and 35. So in this space right here, you're going to put the factors of 28. In this space, you're going to put the factors of 35. And in this space, you're going to put the ones that are common to the two of them. If you want to do it in the hundreds chart, it's the same thing. Pick a color. And just say, like, red is going to be the factors of 28. So 1, 2, 4, and 7. And you're going to go on from there. And that's it, guys.